This question is from GATE 2025, Electronics and Communication Branch, question number 27, and it has been asked from the subject Signals and System on the topic DTFT and Z transform. Okay, it is from this both topic DTFT and Z transform, and it's a 1 mark question. Okay, so question number 27. Let xn with a discrete time signal whose Z transform is xz. Then which of the following statements is a R2? So it's a multiple select question. Okay, MSQ. So more than one option will be correct. So option A, the discrete time Fourier transform DTFT of xn is always exists. Option B, the region of convergence ROC of xz contains neither poles nor zeros. Option C, the discrete time Fourier transform DTFT exists if the region of convergence ROC contains the unit circle. We'll check all the options. Okay, and option D, if xn is equal to alpha delta n, where delta n is the unit impulse and alpha is the scalar, then the region of convergence ROC is the entire z plane. Okay, so also you can refer this NPTEL reference lecture number 11 DTFT Introduction to Z Transform by Professor S.C. Datta Roy, Department of Electrical Engineering, IIT Delhi. You can refer his YouTube link. Okay, so coming to the solution. Okay, first of all, let me write the definition of Z transform and the DTFT. Okay, so the bilateral Z transform of a discrete time sequence x of n is, I can write x of z is equal to summation n goes from minus infinity to infinity x of n z power minus n. Okay, and for this Z transform, the ROC is the set of z values for which this sequence converges. Okay, so ROC, I can write set of z values for xz converge. Okay, similarly let me write the definition of DTFT. So DTFT, it will be, I can write x of e power j omega, which is equal to summation n grows from minus infinity to infinity x of n e power minus j omega n. Okay, e power minus j omega n. So this exists if and only if uh, I can write exists if and only if its z transform, like x of z, converges on the unit circle. Like whether DTFT exists or not, it will defined by the by its Z transform. Okay, if the Z transform uh, includes the unit circle, okay, unit circle, then we can say its DTFT exists. Okay, and unit circle is like Z is equal to e power j omega. Okay, so if this include ROC includes, then we can say it's a DTFT exists. Coming to all the options, so check. Now we will check all the options. So option A, what it says, option A, the DTFT of xn always exists. The DTFT of x of n always exists. See, the always exists sentence, this statement is false. Why false? Because if I consider x of n is equal to e1, so for this signal, z transform is not z transform. Like if I write for this xz, it will be 1 by 1 minus z inverse, and its ROC is like mod z is greater than 1. So it is like outside this unit circle. So it is not included my unit circle. So Z transform exists, but its ROC is exclude this unit circle. So I cannot say that this DTFT exists for this signal. So this statement is always you cannot say. Okay, so this statement is wrong. Option B, the ROC of XZ contains neither pole nor zeros. This statement is also false. Why? ROC contain may zeros. Okay, ROC may contain zeros, but not poles. For example, if I have x of z is equal to z minus 0.5 divided by z minus 0.3. So here you can see my pole is at 0.2. So it includes these zeros. Okay. So this statement is false. Coming to option C. Option C is the DTFT exists. The DTFT exists if the ROC contains the unit circle. So this is the standard definition of DTFC. So if it contain ROC contains the unit circle, then DTFT exists. So this is true, perfectly true. Option D, if xn is equal to alpha delta n, then ROC is the entire z plane. So ROC is entire z plane. So this statement, so if I find this x of z, so it will be summation n goes from minus infinity to infinity alpha del of n z power minus n. So this n exists at 0, n is equal to 0. So I can write, so z power minus 0 is 1. So alpha summation of del n. So it will be alpha. So since neither pole nor zeros, so I can write this, since it's a scalar, so I can write, so ROC is entire z plane. Okay, so this is true. So from this I can see option C and D both are true. Both true. Okay, so you check this option C and D both are correct for this case. So this ROC, this exists even in converging unit circle, this is true, as well as this xn is equal to alpha delta, and then this ROC is entire z plane, this is also true. So option C and D for this question. Okay.